Hello, Brittany. So welcome to spring 2020, right? Wake up to inch of snow outside. That was wild. Ours seems to have mostly melted already though, so that's good. We're just going to do some questions today, whatever people have questions on. So if you want to post some of those, comment, tell us what you'd like to work on. We're going to focus on, I've got the practice exam open, and then also the extra review. I have that open as well. Good afternoon, Alyssa and Rachel and Brittany. All right, Rachel has a question about number 8 on the practice exam. Let's do it. Let's see here. Okay, did you find the data for this, by the way? I didn't really clearly label where the data were. Were you able to find that? Yeah, so I should have had in the title here, there's a practice exam 3 data file. So if we go in StatCrunch, oops, wrong browser there. Let's see what we here. And you go in your group and scroll, it's like all the way at the end. And then you should be able to answer. So there's practice exam 3. Yeah, same with 11 and 12. It's the same data for those. So if we go look at where did it go? Number 8, we've got the homework column. And so you can see that here, there's this homework column. It's for, I think it was like the grade out of 200 on homework or something. I can't remember what it was. Yeah, out of 200 possible. We wanted to create a 95% confidence interval for the mean. Are the conditions met? Are the conditions met? So does anyone remember? We're looking at number 8 on the practice exam. Does anyone remember what the conditions are in order to be able to do a confidence interval about the mean? There's like a couple of things could be true here in order to be able to do that confidence interval. It's either QQ plot has to be linear. Okay, what is that testing? So it's tested by whether the QQ plot is linear. But what is it actually testing? What are you looking to determine when you look at that QQ plot? Right, you're right. You're testing whether or not the variable is normally distributed. So either A, the sample comes from a normally distributed population, and we can either be told that or we can test it, as Brittany noted, with a QQ plot. Or B, what is the other option that could also be true? So either it comes from a normally distributed population, or what else? These are the conditions met. There's no P here, it's not a proportion. It's a mean. We're finding a confidence interval for a mean. So this is the other one. Gotta know this, folks. Gotta know it. The other one is that n is at least 30. You have to have a large, relatively large sample. 30 is not a perfect cutoff. We showed in our first example from 8.1 when we were doing that in class after the break, the first online class we had. We looked at the sample means of different sizes, and even 30 was a little skewed right. But by the time you get up to over 30, then your means are approximately normally distributed, and that's the key. So one of these two things has to be true. So let's go back to the data. We have a sample size of 26, was kind of close. So it's less than 30. 30, again, is not this hard magic cutoff, so we're a little low. So let's see if we're normally distributed or approximately normally distributed. Let's do a QQ plot. And we want to do a QQ plot of homework and title this QQ plot of homework. Okay, compute. It doesn't look too bad. What other graph could we also look at? We can do the QQ plot to check for normality. And what other graph could we also do? Daniel's right. We could also do a histogram. We had talked previously about a box plot sometimes that I find them hard to read for normal distribution. So histogram of homework. Ooh. Ooh. Okay, well, the QQ plot looks relatively normal, but look at the histogram. So the problem with the QQ plot is it deviates a little bit from the line in the middle, and then there's this big outlier down here. Looking over here, it looks like super skewed left. Sometimes the problems with the small samples is the width of the intervals can really affect it. So like if we do a width, right now I think they're 10. If we do, whoops, not that. If we do a width of 5, what does that look like? See, it looks pretty skewed left to me. Could try a width of 15 for really big ones. That looks a little more, but boy, those seem, I don't know what I answered here in the solutions, but now that I'm looking at it now, like, boy, that does not look good. 10, I think, was the original. I'm just gonna delete this. So that looks pretty skewed left. So I don't think so. I would say no. Let's take a look and see what I said when I made the key solutions here. Let's see what I said. Curious if I'm consistent or not. Hey, it does not appear so. There's an outlier, right? So I think that outlier is the red flag to me. If the QQ plot is relatively linear, like okay, but the outlier, and this actually, the n at least 30 also has with no outliers in it, incidentally. So it looks like we don't have at least 30, and there's an outlier, and so it's not approximately normally distributed. So the answer there is no. And then I think, Rachel, I think you should be able to do maybe, I don't know, do you think you can do 11 and 12 now that we have the actual, now that you know where the actual data is yeah, okay, cool. So for everybody who missed it, in our group, at the last page in the data sets, if you scroll through, there's a practice exam 3 data for the practice exam. Okay, let me get the practice exam up. Any additional questions, or maybe let's pause. We were kind of doing some questions right away. I feel like I'm always rubbing my hands, but it's like cold in the house, and I'm like too cheap to turn the heat up. Does anybody have questions about timing? Where my plan is to release the exam tomorrow at 8 a.m. and then you have all day to work on it and then submit it to the Dropbox just like you normally would by the end of the day, 11:59 p.m. So that's the plan. Does anyone have any questions about the logistics of that and our plan? Okay. Does anyone have any questions, kind of big picture? Do you have any questions about the semester? I know I got lots of good feedback in the survey. I'm actually going to do like a response video to some of the questions there. But while we're here, does anybody have questions about the semester, grading, timelines, anything like that? It's been a while since we've talked about some of those big picture things. So we restructured this at the beginning. The final is optional, meaning the last exam will just be a Unit 4 exam. So there will be a Unit 4 exam. And then if you were really banking on the final to help boost your grade, you can take it. To really make sure that you're serious about it and not really wasting my time grading something that you just kind of blew off and, well, let me see if I do it. Like, to make sure you're serious, if you do the final, it will count in your grade. But sometimes people are like, oh, I'm really close. You know, I'm at 88%. And if I do good on the final, that'll bump me up to the A. And so you're welcome to take the final, and I'm happy to grade it. And but that's totally optional. So there will be a Unit 4 exam, and then the final is optional. So you'd have to do both, like boom, boom, right in that last week. Usually for the final, what I do for my classes in the past, I think we'll do it here as well, especially since you have other classes going on and we don't know when their tests are going to be. We'll have more than just a one-day window for that. We'll probably have like Monday through Wednesday for that. So it'll be a little bit different. Any other big picture questions about the semester? All right, let me know if you do have any. I got some really good comments. If you haven't done the survey yet, please do so. It is really helpful for me to kind of get the feedback that's there. And then I'm going to do a response video to some of the questions. So you'll see kind of on the news post here, I think three posts down, there's a spring 2020 online feedback Google survey. Lots of good responses so far, but I'd appreciate your comments there. And if you have questions, you can post them there. I will answer those questions kind of in a video for everybody. All right, let's go back to review, since everybody who's here is probably, like anybody who's coming is probably here by now. So let's go back to the practice exam or the exam review, some additional questions that normally I would have done in class. Does anybody have any additional requests that you wanted to ask about? All right, number 7. This is in the practice exam, correct? Okay. All right, number 7 and then number 9. Okay. All right, both probability questions. In fact, you've hit on the problems that most, let me rephrase that. If people struggle on this unit, these two are the ones. They're actually both from chapter 8. And chapter 8, in my opinion, feels like the most abstract. Like you're doing these probability questions, but it's like weird. There's like weird things going on. So let's take a look at number 7. Suppose faculty believe an exam with 100 possible points should have a mean of 75 and a standard deviation of 10. If we assume the exam scores for all classes are approximately normal with a mean of 75 and a standard deviation of 10, which in fact, you don't want that, because that means you have a bell-shaped curve. The mean is 75, and then it's 65 and 85 and 55 and 95. Most of my tests actually are like skewed left or right, depending on how you look at it. 5 or 6 A's, lots of B's, plenty of C's, and then maybe a few D's and maybe an F. Like they're mostly A, B's, and C's for this class. So the question here, and how you know it's a chapter 8 question, is the bold part. What is the probability that a randomly selected sample of size 25 would have an average of less than 73 on a particular exam? So this is a probability question, but we're finding the probability that a sample mean is less than 73. So from chapter 8, we know that, well, let's see, going back up to the one we just did, where was that one? Was it 8? Are the conditions met? We have to have 23 with no outliers, or our sample has to come from a normally distributed population. So if we go up here, if we assume the exam scores are approximately normally distributed. So we can assume they're approximately normally distributed. We only have a sample size of 25, but they are normally distributed. So that means the means will also be normally distributed. We're going to use a normal calculator, but before we can use the normal calculator, let's go over to StatCrunch. You know this. Stat calculator's normal. We need the mean and standard deviation. So we're going to have to figure that out. And so back to the practice exam. Here's the key. The mean of the sample means, and you should have this written down somewhere, is the same as the mean of the population, which in this case is 75. Whereas the standard deviation of the sample means, does anybody remember that? Do you have it written down? You should know it. Give you a hint, it involves a division. Right, sigma over square root. Yep, you got it, Daniel and Rachel, good. Square root of n, okay. And so that will be, this one works out kind of nice. I think this is when we were using calculators, and now it's like super easy in StatCrunch, but I made the math work out nice because you just get 10 over 2, which is 5, or 10 over 5, which is 2. So, you know, this one's a little bit simple. You don't need to do that, by the way. You can just use your calculator and do that. I would not round. So like if this was 26, I would do like 6 decimal, just copy paste. Just copy paste, don't round there. Because you're not doing a final answer. It's part of a calculation, so you don't want to round at that point. But ours is easy. So the mean is 75, standard deviation is 2. Now again, this is the distribution, not of exam scores. This is the distribution of sample means for samples of size 25. And so we're going to find the probability of being less than or equal to 73. And so that's about 0.159, 0.16, depending on how you want to round. It's not a big deal. So this we'll see, I guess we should say approximately 0.159. So that's the probability that a randomly selected sample of size 25 would have an average of less than 73. Does anyone know, this is what I hinted at is one of the most common mistakes, the most common ones that people struggle with. Does anyone know the common error on this one? Yeah, Brittany said not finding the standard deviation for the sample. That is exactly correct. So the common error on this one, I think the answer is about 0.4, is just putting mean standard deviation, mean 10, or so mean 75, standard deviation 10, and you get 0.421. That's the common mistake. What that is, that's the probability that one exam is less than or equal to 73, not the probability of getting a sample mean. So Brittany is correct. You have to look at the standard deviation and get that standard deviation of the sample mean. And the way you know how to do that, and this is one of the sections, you're going to get a problem like this. The way you know is it's going to tell you, find the probability that a randomly selected sample would have a mean, or in this case, I wrote average. Next here is a class average of less than 73 unusual. Well, remember our unusual threshold is 0.05 if it happens about less than 5% of the time. And this happens about 16% of the time. So a little rare, but not unusual. And so we would say no, the probability is more than 0.05. So that's 7. Are we good on 7, Brittany? Does that clarify that one? All right, great. And let's look at 8. This one is usually the hardest because the standard deviation is even weirder. So this is kind of old now, a little outdated, 2009 National Health Survey, so it's over 10 years old. More than 1 of every 5 Americans had only cell phones, right? I'm sure that's gone up by now, right? So those are people that did not have a landline, they only had cell phones. This would be good to look up again and kind of see what it is now. So based on this reported proportion of 22.7%, would it be unusual if 90 or more out of 300 randomly selected ECC students were a member of a household that relied only on cell phones? So what we're trying to do, again, this is saying, would it be unusual? So to know if something's unusual, we need its probability. So we want to find the probability of getting 90, I'm just going to write this out, 90 or more out of 300. So I guess I kind of knew right away that this was the other section in chapter 8. The first section was about means, the second section was about proportions. So how do I know that this is a probability question about proportions? Oh, it says right there, based on this reported proportion of 22.7%. But look at this, I'm trying to find the probability of 99 or more out of 300. Like, I don't know, is that obvious to you that that's a proportion? I don't know. Maybe? Does anyone have a way that you know that that's a proportion? That's a sample proportion? Not really? So the key for me is when it says 90 or more out of 300, and so it's 90 out of 300, that's how I know, oh, that's a proportion. So we're trying to find the probability that a sample proportion is at least 90 out of 300. So the way we're going to do that is we're going to do a probability question. But again, we need the mean and standard deviation. So I'm trying to use the symbols here. The mean of the sample proportions is the same as the population proportion. So we should get 0.227. That's the population based on this reported proportion of 22.7%. So that's the population proportion. That's what we should get. And then the standard deviation, I haven't really said this. I need to clarify this. You should make a formula sheet for this exam. Usually I would have one, and we would kind of talk about what to be on it, but things are a little bit different now. So I need to remind myself here in the post, make a formula sheet and then upload that with your test. Because these are some crazy formulas and you don't really use them a ton, and it's hard to memorize something like that. And if you can just look it up in the future, there's not a lot of benefit of memorizing it now. So I'm not going to ask if you remember this one because this one's kind of funky. P times 1 minus P all over N. That's inside the square root. So that's pretty gross. So square root of 0.227 times 1 minus 0.227 all over N, which is 300. And we are going to need a calculator for that. Let me see. Can I use my Desmos calculator? Desmos. Use the scientific calculator here. I like this because then I can just copy and paste. See how that's nice? It gives me the answer there. So I can just copy that and paste it. So that is approximately equal to this number. Excellent. All right, so now I think we're able to use the normal calculator again. We have our sample proportion, which is 90 out of 300. What is 90 out of 300? I feel like that simplifies nicely. 9/30ths, so 3/10, right? So that's the probability that P hat is at least 3/10. Okay, so normal calculator, back to our StatCrunch. Normal calculator, mean is the population proportion, and standard deviation was our funky decimal. I just pasted it in there, 0.02418. And we want to find the probability of getting, isn't it greater than this time? Would it be unusual if 90 or more out of 300? Would it be unusual if 90 or more? So we're going to go greater than or equal to 0.3. Oh, wow. 0.227 is right in the middle, and 0.3 is way over here on the right, and the probability is 0.0013 if we round. Approximately 0.0013, so very small. So yes, this would be unusual because the probability is much less than 0.05. So that one, man, I feel like I could, you know, when you get those practice tests, they're really the ones that are not good practice tests. They seem good to a student, but they're really not good, where the practice test is exactly like the regular test, you just change the numbers. Then that's not good because you're not really knowing what you've learned. You're just kind of copying what you saw. I feel like this one, even if I gave this exact same problem and just changed the numbers, it's still like, it's weird. So I don't know, even if I did that, I think it would still be challenging. So my opinion, section 8.2 is one of the hardest from this, probably the hardest from this unit. I feel like chapter 7, normal probabilities, you just use the normal calculator, not bad. QQ plots, not bad. And then chapter 9's confidence interval, like when you first see those, they're a little weird too, but then once you start doing those, it's just kind of, okay, which command do I do in StatCrunch? How do I read the output? How do I interpret that? And they're all pretty similar, but this section I think is, in my opinion, is pretty weird. So that is number 9. Brittany, do you have any additional questions, or anybody else have any additional questions on number 9? Okay, excellent. Any other requests? I have the review up as well. That's also posted in D2L. We did some of these last time. I remember we talked about the symbols last time. We did some other examples. I can't remember which ones we did, but I know we did a couple other ones too. So does anyone have any additional questions from either of those? Daniel has a question about number 5 in the exam review. The question here is, assuming the sample proportions are similar, which confidence interval will be wider? One based on a sample of 100 or one based on a sample of 1,000? How do you know? Well, let me ask this. There's a lot of research right now, a lot of uncertainty about the death rate due to the COVID-19 infection. The coronavirus, the infection you get from that, there's a lot of uncertainty about that. So you tell me, if we have a sample of 100 individuals that had the virus, we know they had it, they have the antibody in their blood, or they were in the hospital with symptoms. So some of them might not have been hospitalized because not everybody is. It's only a proportion that get hospitalized, but everybody had it. So we had 100 who had it, and say we had 2 people who unfortunately succumbed, pneumonia in the lungs or something happened to them. So we had 2 out of 100. So that's 2%. 2% would be the death rate there. And then suppose we have a different situation. We have a much larger data set. We have a sample of 1,000. We have a sample of 1,000. And again, all of the 1,000 had the virus. Everyone had it. They either didn't go to the hospital, but they had a blood test after the fact, and they have the antibodies in their blood now. So we know they had it at some point, but it wasn't that bad. Or other people were in the hospital. And suppose we have 15 out of those 1,000. So we either have 2 out of 100, which is 2%, or we have 15 out of 1,000, which is 1.5%. So similar rates. My question is, which one would you be more confident is correct? The 1,000. I mean, it seems pretty obvious. Like I got a bigger sample size. So if we did these intervals, in fact, the margin of error on the smaller sample would be wider. And it's actually built into the formula. We could actually do this right now. In fact, you'll see it. But the margin of error always ends up being smaller for a larger sample size. So larger sample sizes always, assuming the proportions are similar, because that's in the formula. So assuming they're similar proportions, a larger sample size will give you a narrower interval. That will always happen. Let's actually do this right now in StatCrunch. How do we do confidence intervals for proportions here? You don't have to answer this, Daniel, but anybody. Confidence intervals for proportions. Brittany's right, stat, and then proportion stats, right, Daniel? Stats, and then proportion stats. With data or with summary? What do we have here? Just summary, Daniel, that's correct. It's so weird, it feels like we have data, oh, we have 15 out of 1,000. But with data means you have person A, did they die? Person B, did they die? Person C, did they die? You have like raw data, which we do not have, right? We have summary. So let's do 2 out of 100. And we're going to do a confidence interval for P. Okay. So, well, one limit is negative. That doesn't make any sense. So 0 to 4.7%. 0 to 4.7% is the interval there. All right, let's do stat, proportion stats, one sample with summary. And let's do 15. It's so weird calling it a success, right? It's a probability experiment, and you're finding the proportion who die. And so in this case, the success is a death, but it's just a probability term. Just feels weird though. So that when we do that interval, and check this out, you see how much narrower that is? But we can actually type these on the next page here. So we have, this is 0. 0 is a lower limit here. 0 to 4.7% or 0.7% to 2.2%. So much narrower. So let me do this. Insert page break. Go to the next page here. So that first one was 0 to 4.7%. And the next one was 0.7% to, I think it was it 2.2%? Am I remembering that? 2.3 if we round correctly, 2.3%. So you can even see there in the example, it ended up being smaller. We don't talk about the formula much, but the formula is P hat plus or minus Z alpha over 2. We just do this in StatCrunch. Whoops, Z sub alpha over 2 times the square root, and you'll recognize this, P hat times 1 minus P hat over N. And so the issue here is if the P hats are similar, the only difference is the N then. And so a larger N in the denominator ends up making that margin of error, which is this part here over on the right, makes it a smaller margin of error, which gives you a narrower interval. So which interval will be wider? It would be the one that's 2 out of 100. That would be the wider one. Smaller sample, more uncertainty, so wider interval. Larger sample, more confidence, narrower interval. Good on that one, Daniel? All right, excellent. Good question. This is an important, like, big picture concept question. I mean, it's one thing to be able to do the calculations, but if all you know how to do is just do calculations, you're really no good to me. So you trust me, we talk about this a lot. You're going to be asked some like concept and explain questions too. So good, good. What else? What else? We have time for plenty more here. Any other requests, or even a topic? If you have a topic you'd like to review, we can do that too. This worked like so much better when we were in class. And I was just like, all right, everybody, work on the practice exam. And then I just walk around, answer questions, work it in your groups, like so much more effective than like, you got to work on your own. You got to ask questions. But if you haven't gotten to it yet, because it's not due till tomorrow, like that's fine. So if you haven't gotten to it yet, how do you do that? So yeah, it's tough. It's tough. Oh, and I just realized one thing I have to do. It's kind of, it's not great, but one thing I'm going to have to do is make sure that we don't access stuff that we're not supposed to. So some things are not going to be available in D2L tomorrow because you want to just be sure you're using that. We talked about a formula sheet because you have these weird formulas. So you're going to want to make a formula sheet. And then of course you need StatCrunch and you need a calculator and whatever, all the usual stuff. But it's hard because you're at home and this is not proctored. Normally when I teach online, these exams are proctored. And so I know as a student, if I was stressed out, which pretty much everybody is, it would be super tempting to open up the practice exam and the key and then the solutions and have that there. But that's not fair. It's not cool to do that. So some of that stuff, like we can't let you have that stuff. So just kind of keep in mind, you want to do all your studying today, get done, and then tomorrow, once that exam is posted, you sit down when you're ready. You can work, you can take as long as you want, and you can take breaks if you want to, but you're just going to be doing the exam tomorrow, and you'll just have access to that stuff. Okay, I don't know, chat is quiet. Anybody else have any other questions about anything? And while I'm waiting for anyone to answer, I have an interview. So I don't know how people like who have like really busy work. My work is I have 2 or 3 hour long sessions like this every day, and then I have some grading and other stuff. People who have to like work in real meetings and have their kids at home, like I don't know how they do it. So Rachel, I feel like this is a common question. Rachel asked, if you don't have the chat up, she asked about when do you use the n times p times 1 minus p greater than 10 versus n greater than 30. The key is means versus proportions. So the one that we looked at earlier, wait, it wasn't in here, it was in the practice exam. I think it was number 8. So the key here is, suppose you wish to create a 95% confidence interval for the mean. So because this is a mean, on your formula sheet, you want to write, okay, the conditions for the mean are either it comes from a normally distributed population or the sample size is at least 30 with no outliers. So those are the conditions for a mean. And then for a proportion, we haven't done one of those yet. I don't think there's, like we should have checked it here, I suppose. I'm not going to ask you to determine if it's unusual if you can't do this probability question, but if we wanted to know, hey, can I do a confidence interval, or is that p hat normally distributed? The key here is N has to be less than 5% of the population, which is almost always the case. Like here, the question is 300 randomly selected students less than 5% of all ECC students? And I think we have about 10,000 students. And so 5% would be 500. So we're less than that. There's some kind of abstract reasons about why you don't want to have too large of a sample. But so that has to be true. And that one's almost always true. And you have to have N, this is the one you're talking about, P times 1 minus P to be at least 10. And so in our case, we would have N is 300, P is 0.227, 1 minus 0.227, and that definitely will be at least 10, right? That's pretty big. That's pretty big for ours. I'm just gonna go over here, paste that over here. So that's 52.6. So it's definitely true. It's definitely greater than 10. So we could have done a confidence interval for this question. In fact, I wonder if we could do, I bet we could use a confidence interval to answer the question if it's unusual. Sorry, I'm easily distracted. But let's do that. Let's do, I'm gonna just erase one of these options, edit 90 out of 300. So look at this. The lower limit is 24.8%. The upper limit is 35.2. 95% confidence interval, 24.8% to 35.2%. And you'll notice that we think it's between 24.8 and 35.2 for ECC, and the national population proportion was 22.7%, and so ours is higher than that. So it probably would be unusual because it looks like it's different from that. So I don't know, that's a little bit different way to look at it. But anyway, that is not Rachel's question. So the key is, if it's here's the easiest answer. If you have a question about a mean, there is no P. So you can't check N times P times 1 minus P because you don't have a P. You're looking at a mean. For a mean, all you have is your sample size. And so, but that's the key. It's all about, are you looking at a proportion or are you looking at a mean? The N times P times 1 minus P is for testing a proportion, and then the N greater than 30 is for testing a mean. So that's a good question. Yep, it's a good one. I see a lot of confusion on that. Again, these are kind of abstract concepts, and now we don't have class time to go over and over and over them together. So it's tough. I will say that the rest of the semester, interestingly, you get in a real rhythm. And then I think chapter 10 is going to be new, and then the rest of the semester will almost be easier. It's just a lot of new applications of things you already know, and it'll get in a real good rhythm. I think honestly, unit 4 is easier than unit 3. I would say unit 2 with the probability is the hardest, then unit 3, then unit 4. Unit 1 is pretty easy for people, just sampling and stuff like that. Okay, any last requests before we call it a day? Okay, I'm not seeing anything. I'll post on D2L. I'll post this replay, which maybe you can watch, maybe you don't need to. But I will also post those details about the test. Make sure you finish your studying today. The test will be posted tomorrow, and access to other items will be turned off. And you should make a formula sheet. So make a formula sheet today. You should be working on that, putting some of this stuff in there. And I'll ask you to include that, either like take a picture of it, submit that with your exam, or if your formula sheet happens to be typed out, you could just put it with your exam. But I'm going to ask you to see that as well, so I kind of know what tools you had while you were working on your exam. The exam will just be submitted to the Dropbox like usual, just doing your work at home. Okay, thanks everybody. I'll sign off for now and look for details for everything on D2L.